There are three different types of symmetry that we're going to cover in this lesson. We have symmetry with respect to the x-axis, to the y-axis, and to the origin. So this is your technical definition of symmetry with respect to the x-axis, and it says a graph is symmetric with respect to, and that's what WRT stands for, is with respect to the x-axis if for every point xy on the graph, the point, and you can see over here, if we have the point xy on the graph, then we also have the point x negative y on the graph. Now, while this is technically our definition, is that for every point xy, we have a point x comma negative y. If we just look at our graph, we can visually see if this is symmetric with respect to the x. So here, if this is my line right here for my x-axis, you can see here that the top of this mirrors the bottom half. So, for example, if the graph is symmetric with respect to the x-axis, the point 3, 2 is on the graph. So let's say that this point right here is point 3, 2. Then what other point is also on the graph? And that would be 3 comma negative 2, because we would still be going over positive 3 on our x-axis, but now I'm going down the same amount as I went up. So this would be negative 2. Okay, but again, we can just visually look at this. Over that x-axis, does the top of it mirror the bottom half? And in this case, yes, it does. When I have symmetry with respect to the y-axis, and when I have symmetry with respect to the y, this is also known as an even function. It says a graph is symmetric with respect to the y if for every point xy on the graph, the point, and we can see again from this diagram, if I have the point xy, we also have the point negative x comma y. Now, while this is the definition from your book, we can just visually look at this. Now, instead of using the x-axis for a mirror, now we're using that y-axis for a mirror. And you can now see that this left side mirrors the right side, right? If you took this and you folded it over, every point would land on that other point. So, for example, if the graph is symmetric with respect to the y and the point 3, 2 is on the graph, so we'll still call this point right here 3 comma 2. Then the point what would be on the graph? Well, here I'm still going up the same y. So my y won't change. It'd still be going up a positive 2, but now instead of going to the right 3, now we'd be going to the left 3, so that'd be negative 3, 2. Then our last type of symmetry is symmetry with respect to the origin. And if it is has symmetry with respect to the origin, this is also known as an odd function. So this one is a lot easier to kind of put together. You can just remember O from origin, O for odd. And so if it is symmetric with respect to the origin or an odd function, it says that the graph is symmetric with respect to the origin if for every point xy on the graph, the point what is on the graph. So we can see if I have x comma y, then down here we have negative x, negative y. So if a graph is symmetric with respect to the origin, the point 3, 2 is on the graph. So we'll call this point again 3, 2. Then the point what would also be on the graph. Well, now I'm going, instead of positive 3, we're going negative 3. Instead of going up 2, we're going down 2. We've got negative 3, negative 2 over here. Now, with these are visual. Is it mirroring the x? Is it mirroring the y? This one, if it has origin symmetry, you should be able to turn your paper 180 degrees and it looks the same. So Here's my graph. And if I turn my paper 180 degrees, this looks the exact same. So we can just turn our paper upside down. Does it look identical? If it is yes, then origin symmetry. Okay, so these are your 3 different types. We'll go over example 1, which will ask us a question about what kind of symmetry we have.